Okay, so quick introduction to logarithms today. Big key here is to recognize the log is the exponent. This will be kind of the mantra for everything we do. You want to recognize when you see logarithms written down that we're actually finding an exponent. Hopefully that'll be clear in a moment. So if I look at something like this, 2 to the exponent 3 is 8. I don't think anybody's going to debate that. So our log is the exponent. So we're saying if we're doing a logarithm with this question, or with the similar values from this question, we're trying to find the exponent. We're trying to find the 3. So if we rearrange this, it would be written this way. Okay, so if we read this through, log base is 2. The base was 2 up here. The 8 is the other value. And the exponent, again, is the 3. So the log over here is equal to the 3 over there. And again, to read that out, this is the way it reads. Log to the base 2 of 8 is equal to 3. So just a bit more clarification here. If we look at the logarithm specifically, log base 2 of 8, really what the question's asking me is which exponent of 2 is equal to the 8? So 2 to what exponent is 8? And of course, if we sort of think about it in these terms, the 8 can be rewritten as 2 to the exponent 3. We saw that already. And so essentially, this is what it's asking me to solve for. What is that unknown value? What is that little red thing up there? In this case, it's a 3. In different forms, of course, it could be written as 2 to what exponent is 8, 2 to what exponent is 8. Again, sort of understanding that this right here is really asking me this question. What is the exponent on the 2 that gives me the 8? So we'll try a couple here in a more practical way. And so 4 to the x is 64, so we'll rewrite it as a logarithm, sort of the first part of the question, and solve. Now again, the log is the exponent, so the log helps us find the exponent, which means that the x will be isolated. That's how we solve things. And the rest of the question will be log, the base is 4, and 64 is again that other number. So this rewritten as a logarithm is this, and then in order to solve it, essentially we're being asked 4 to what exponent gives me 64, and of course it's 4 to the exponent 3 that gives me 64. Now whether this is easier than this at this point is not that important. We're going to have both options. Write things out this way, write things out in logarithm form, and determine which one's going to help us more. Eventually this will help us more on questions that we have difficulty with. Initially this might be easier just to sort of say, well, I can tell that that's supposed to be a 3. So continuing on here, rewrite this as an exponent. Again, this is the exponent. So this is sort of saying, find me a value for this. We'll call it x for now. And so this whole thing could be equal to x. X is the exponent on the expression. The 2 is the base. It's the base of the log. It'll be the base of the exponent as well. And so 2 to the exponent x is 32, is the inverse of the original question. So this question is asking me to solve for that. What is the exponent on 2 that gives me 32? What is the exponent on 2 that gives me 32? So these first few questions are really just kind of understanding how to interpret them, go back and forth from one to the other. So solve log 3 to the base 81, log base 3 of 81. And we would basically have two options here. One is to write the question as a logarithm and think of it as a logarithm. X is equal to, the exponent is equal to this. And then again, what it's asking me really is find the exponent on 3 that gives me the 81. The other possibility is just to rewrite it as an exponent. So if x equals log base 3 of 81, that's really the same as the base 3 to the exponent x being 81, And then we can sort of solve it this way and say, I'm recognizing that I have 3 to the exponent x. I have to have 3 to the exponent something here so that I can make my x's equal. And then basically, because I have an x here and a 4 here and the same base, hopefully it's fairly clear that that must mean that x is the same as the 4 value because the two terms are equal. When we have a question that we can't solve, so 3 to what exponent is 64? I don't know. We'll rewrite it as a logarithm. So again, the exponent is the isolated value. The base is the 3. And the 64 is, of course, the remaining value. This is a question that I can't solve. My options are pretty limited. I could pull up a calculator and try some stuff. I know it's asking me 3 to what exponent is 64. I know that 3 to the exponent 3 is 27. 3 to the exponent 4 is 81. So I could just try 3 to the exponent, I don't know, 3.5 and see what that gets me. 46. Not big enough. So then I could try 3 to the exponent 3.6 and see what that gets me. 52. Still not big enough. And so on and so forth. Alternatively, of course, I'll use the logarithms. And the way we work the logarithms on a calculator, you've probably noticed you only have a single log button on your calculator. It just says log, it doesn't say log, and give you the option to put in a base. The way it works is the log as written is log base 10. If we do this calculation, it's essentially doing log of 64 base 10 divided by log of 3 base 10, and it works out to be the same as log of 64 with a base of 3. So to punch this into the calculator, we will simply punch in log of 64 divided by log of 3 and find that the answer is 2.128. Three decimal places is kind of a nice amount here. And again, of course, I should be saying that this is approximately equal to that. Now, as we just mentioned, if we're looking at something with a base of 10, the calculator actually does base 10 by default. And so my exponent will be equal to log of the base 10 of 128. I could write that just as a log with no base written. Again, base 10 is understood. And so now it's going to be log of 128. And I don't have to do the base 10 part. So it's 2.107, I guess. So again, what this is telling me is that 10 to the exponent 2.107 will give me 128. So let's try that. 10 to the exponent 2.107. And I think we can assume that it won't be exact because I had to round off my answer, but you can see that it's about 128. Which means, of course, I should be indicating that this is approximate. Okay, so last example here. Solve this using a calculator. So log, if we rewrite it, x equals log of this. Again, to use the calculator, it's log of the 81 divided by log of the 4. And when you punch that in, you find that x is approximately 3.17. So you can test those, make sure you know how to use them. Some calculators do work in reverse, especially older calculators. You will tend to type in 45, then hit your log button. A good rule would be if you use sine 45 to get your answer, then you will also use log of whatever your numbers are in that order. If you typed in your angle before your sine, before you hit cos, then you'll have to type in your numbers before you hit your log. And good luck. Ask questions as always.